Well, welcome back to NorCal 715, part 2 of the Marantz repair. The customer approved the estimate. I got the parts on order. They arrived. So I've got some 2SC945s, some 2SA733s, those are the audio output transistors, pre-drivers, a 330 ohm quarter watt resistor, and two 0.33 ohm 5 watt resistors, those are the emitter resistors. And I got two STK3080 Mark IIs, and this one's kind of shiny, but it is an STK3082, the driver IC. So let's go ahead and rip the amplifier module up enough where I can get these things unsoldered, get them in here, we'll do a couple tests, and see if that takes care of the customer's problem. Well, you certainly don't see anything like this in products manufactured today. Look at this, two sets of plugs. So all I have to do is unplug those plugs, power supply and speaker connections, and then this is the audio input. There's actually a plug on it as well, so the complete amplifier module just lifts out of the unit. It's got two screws on this end, four screws on this end, then there's a little circuit board that mounts right here with one screw that holds it down, and then the whole amplifier module can be taken out. So I'm going to need to unsolder these pins here to get this to lift away, because the other screw for the power amp is hiding back in here. And once we have this off, we can do some ohm checks on it to make sure everything is as it should be. Actually, I could do this job without taking the board off, because they did thoughtfully provide some screw holes so that you can actually reach down in here, loosen the screws to the power amplifier module. I still want to take it off. It's just going to be that much easier to replace these emitter resistors. I'm going to have to fabricate a lead to connect the two commons back together. So we'll get the solder sucker warmed up and we'll get these all unsoldered here. And then we can take this completely off. It'll make changing this chip up here so much easier as well. Alright, that's loose. One screw. The preamplifier board can be taken completely out. There's that burnt 330 ohm resistor. Next, we'll zip out the screws for the power amplifier ICs. Oh, did you notice that? The cover for the speaker relay is loose. Somebody may have cleaned the contacts on it one day and never snapped the cover back on it. Either that or it's just a manufacturing defect. Now it looks like it's been pried off. It's hard to see, but I see a little dimple down there. Anyhow, we'll just leave it kind of loosely on there. Wow, that screw back here is loose. It's never been tightened. That side's not even screwed down at all. There we go. And they look like they had adequate heat sinking. This one could have used some more compound. It only made contact on the outsides. But that's not the one that's blown. The one that's bad is this one over here. Yeah, I definitely think somebody's worked on this, because this tab's been bent up as if someone took the circuit board out without maybe realizing the whole module comes out quite easily. I don't know why someone would bend up this tab. This one on the other side is exactly the same way. It's been bent up, so yeah, someone's been in there. So let's try to bend it back into place. That looks good. Now the way this is supposed to work is when it's on there, it grabs the circuit board between the upper and the lower tangs, keeps it retained in there. Relay cover came off. We'll deal with that later. Probably going to go ahead and clean the speaker relay contacts anyhow. So we'll just go ahead and re-verify what we saw before. So pins 2 and 3 and pins 8 and 9. That's the good one. Ooh, now they both test good. Interesting. Was it something on the driver board the whole time? I know we had open emitter resistors. Yep, that one's open. So I'm still questioning this power pack. I'm going to go ahead and change it. Huh, interesting. Now I do an ohm check and it's shorted. I swear it was just not shorted a second ago. Interesting. You saw me do that. Just a minute ago I did the same ohm check. And it did not check shorted. Well, let's go ahead and get it unsoldered and we'll check it. And we'll see if it'll cooperate and come out of there halfway easily. Oh yes, very nice. So here is the schematic on it. We'll go ahead and lay it back down there. All I'm interested in is TR7 and TR8. So pins 2, 3, 8, and 9. So here's 2 and 3. Dead short. 8 and 9. Dead short. So I'm going to go ahead and grab one of the new ICs and we'll do the same checks just to verify that the transistors are in okay shape. Okay, one of the brand new power packs. So let's just measure 2 to 3. I see 1.7 volts drop. Reversed open. I see the same drop. So that's a very good sign. So I'm going to say that chip tests good. I like what I see. Now let's go ahead and test the second one. Let's go ahead and check 2 to 3. Open. Wow, open both ways. The other one showed a little bit of resistance. Other than that, I don't know if it's just out of the range. Let's just look at ohms. 9.4 megs and falling. 9.4 megs. It just must be the junction voltage is slightly different on one of these two chips. They both come from the same run number. Interesting. Well, have to roll the dice and put them in there, see what happens. That's all we can do. So just because I know someone's going to ask, why didn't you check the old chip? So we'll do that right now. Let's check pins 2 to 3 and 8 to 9. I see nothing. Nothing either direction. So there are the two emitter resistors. We'll go ahead and check them out of the circuit. Nothing. And that one's good. The new ones may look a little bit different, but they're still 5 watt 0.33 ohm resistors. Very good. Okay, so I have a couple of leads attached to the resistor. Sorry, it's out of focus. Just some wire leads bent around there, and we'll just go ahead and try and mount those in there. I'm going to try to stand them off the board just slightly if I can. And so we'll just go ahead and tack them onto the board. So next I'll go ahead and clean the excess heatsink material off of the heatsink. Somebody commented in my last video, they didn't see any acetone. Here you go. Nice and clean. Alright, so it came with these little pre-packaged heatsink compounds, and we'll just go ahead and use those. Tear off the top. So I'm just going to go ahead and place it down, apply a little pressure, move it around, and then we'll try and lift it off and see if we have good adhesion. It certainly doesn't want to come off. That looks pretty good for no screws. So I want to see a little bit of compound oozing out around the chip. You can just barely see it there on the bottom, so that's good. That means I have good adhesion. Once again, just a small amount of compound oozing out as it presses down on it. Sometimes you can press in the middle and get a little bit more. And very hard to see on the bottom, but yes, there is a small bit of compound oozing out there as well. Next, I'll go ahead and mount the circuit board back up to it. The pins lined up almost perfectly. So I'll go ahead and put that one screw back in it. I think there was supposed to be a screw over here. Somebody lost it when they worked on it previously, so we'll have to come up with some backup screws. Alright, well I've got all the pins soldered in place. They all look really good. I don't see any bridges there. There's the other channel. Good adhesion to the pins. I need to go ahead and pull the speaker relay out and see if I can get to the contacts to clean it. Alright, well here is the speaker relay. There are the contacts. As you can see, there's a little bit of over travel, which is good as it pulls completely down to the magnet. We want that. So let's go ahead and pull the spring off the relay. Then we can take this contact plate and very gently swing it up and out. And then we can actually look at the contacts. Look at that, they are pitted just a little bit. We'll go ahead and give them a buff with a piece of paper. Well, they certainly look much better. This one may require a bit more. It looks like it's had some arcing going on, possibly very high volume levels and a high resistance contact possibly. I'll try to give it a little bit more scrub, see if we can get that cleaned off. Usually a piece of paper is just abrasive enough to go ahead and polish up these contacts without doing any damage to them. Especially works good on very low current contacts, like if it's a gold flash contact. Definitely looking a little bit better there. Now to get this side, we're going to have to actually cut a piece of paper, lay it in there, close the contacts on it, and then slide the paper through the contacts. Okay, so I've got a piece of paper in here, and I'm just going to go ahead and just polish the contacts. I don't think any solvent is necessary. I really don't want to use any kind of solvent that has any kind of lubrication on it because it's going to attract dust and dirt over time. So it's kind of tough to see, but we did definitely get some stuff off there. Well, let's go ahead and snap the cover back on it completely this time. There we go. Cover's back in place. Now we can go ahead and remount it back on the circuit board. Okay, the speaker relay is back in place. Now let's just flip it over and see if it falls out. Hopefully not. So I'm just going to go ahead and put a couple of tabs on it. Now from the bottom I'm going to press up and try to heat them both at the same time. There it is. Now we'll go ahead and solder the other 4 leads. And touch up those 2 as well. Okay, I'm going to say at this point the power amplifier board is complete. I believe we've done everything we need to do. I do see some caps. I guess I can throw an ESR meter on them. I think they're only used in the time delay and the relay pull-in circuit, but we'll check those just to make sure they're working. I believe these are the input filter caps for the power supply. Okay, ESR meter is good. Lead integrity is verified. 0, 0, 0, and 0. 1 ohm and half an ohm. Perfectly good. Okay, so I know somebody's probably going to notice that I had this clip on incorrectly, where the circuit board was not under and over the 2 tabs. It was just over the tabs. So anyhow, I went ahead and took care of that. So next we'll go ahead and tackle the preamp board. Alright, so here is the audio driver preamp assembly. So we're going to replace this STK3082. We're going to go ahead and replace these 2 driver transistors and this one burnt up 330 ohm resistor. In addition, we'll go ahead and check all the associated components, the diodes and whatnot in this channel. We'll go ahead and ESR these capacitors in both channels just to make sure everything is okay. So before I get started on this board, I just wanted to take a quick look. It's hard to tell, but I think that chip may have been changed at one time, and whoever changed it left out the screws. You can certainly see that there have been imprints of where screws have been there in the past, but as of now there's nothing. So when we get this going, we'll go ahead and put those screws back in it there as well. Alright, we'll start by unsoldering the STK3082. Alright, there we go. Let's go ahead and unsolder QN05 and QN07, as well as the burned up resistor, which I think is RN21. Next, we'll go ahead and get some acetone. Let's have a little piece moistened here. I'm just going to try to wipe off the circuit board. Much better. This resistor had some carbon coating on the bottom of it. Went ahead and cleaned that up. Looks much better. You can see RN21. Just a very small little burnt spot right there, but I think it's going to be okay. Now I've labeled them with a C and an A because this one is the 2SC945 and this one is the 2SA733. They go in exactly the same because they are the same part. Fold those leads over just a little bit down there. Alright, transistors and resistors are soldered in place. So I went ahead and, might be hard to see on the camera, but I went ahead and marked with a red marker where all the capacitors are, and we'll do a quick ESR test on these 6 capacitors right here. Okay, so let's go ahead and ESR these capacitors now. I think these are very low value caps. 1.5 ohms. Just under 2 ohms on that one. Just over 2 ohms on that one. and about 1¼ ohms. We'll check the value on that and see if it's acceptable. 0, 0, those are the power supply input filter capacitors for the pre-drivers. This is a 50 volt 1 microfarad capacitor, and it measured just over, I think it was just under 2 or just over 2 ohms, which is perfectly fine. This one that is about 1.5 ohms is a 4.7 microfarad capacitor at 50 volts, and it's perfectly fine, these two. So all 6 capacitors on this board test perfectly fine. Alright, so I went ahead and selected a couple of larger face with washers screws to replace the missing ones on this heatsink. So I've got it all cleaned up thanks to the Magic Solution Acetone. Next we'll go ahead and apply some heatsink compound to the back of the STK3082 and we'll put it in place. We'll go ahead and apply the supplied heatsink compound to the chip. Quality feels okay. It's nice and thin, so it should fill in all the voids on the chip and on the heatsink. So next I'm just going to go ahead and try to line up the pins. Look at that. And I'm just going to let it fall naturally against the heatsink. And then I'm not going to apply any pressure. I'm going to pick it back up and see what kind of transfer pattern. Mostly at the bottom, which is good because I have a screw that's going to, a screw and a spring that's going to pull the top down just a little bit. So there's the tiniest bit of pressure. And we have pretty good heatsink compound adhesion at that point. So let's get the bracket and the screw back in it now. So I have the bracket and the screw ready to go, and I went to put it on there, and I took a look at the back of it here. There's the screw hole and the alignment pin for the spring, but they're underneath the chip. We're going to have to pull the chip back out and trim those legs so they don't have that bump in them anymore. Alright, well I've got all the pins trimmed, and you can certainly see by the length of the pins on the old IC they were much shorter than this one, although it does have a slightly smaller profile. We'll still get them lined up okay, and I think we're going to be fine, because even if I line up the tops of the new and the old IC, the pin length on the new IC ultimately is just slightly longer than the old IC. So let's try round 2 again. Alright. Now it does fit, and it gives me enough room for the screw. Okay, so I do have the screw in it. It is loose still. I haven't tightened the screw. So I went ahead and I pushed the chip up as far as it would go, and I want to see how much lead protrusion there is. There's still about 1/16 of an inch. I know that when I tighten the screw, the spring is probably going to push it down, so I'm just going to go ahead and put it down about 1/16 of an inch, and we'll get that screw nice and tight. Now it looks as if we have probably 1/8 of an inch of protrusion. Okay, all the pins are soldered. They have plenty of protrusion. It looks like it's up pretty good against the heatsink, just barely down on this side, but it's a very small power chip on a very small heatsink, so I think we're going to be okay. Okay, so let's go ahead and we'll just test the junctions of all these diodes. 579, 568, 590, 588. So I thought, just for the heck of it, let's go ahead and test the 2 transistors that came out of this unit and see if they're actually bad or not. I don't suspect they're both bad, but I do suspect one is being bad. Let's start with the NPN 2SC945. Pin 1 to 2 is 31.6 ohms, and pin 2 to 3 is 0.75 ohms. That one is definitely bad. Now the PNP 2SA733. The gain of the transistor is 205, and the forward voltage is 0.635 volts, or 635 millivolts. So one is good and one is bad. Okay, so even though it doesn't look like the pins have enough protrusion over here, if I tip it down, you can see they have plenty of protrusion. So let's go ahead and solder those up. Okay, there it is, all soldered up and ready to go. I think we can go ahead and drop the amplifier module back in the unit right now, and we'll just go ahead and see what's going to happen. Okay, so for my first power up, what I'm going to do is go ahead and turn the unit on with the power switch. This one does not have a microprocessor controlled relay, so it has an actual click on, click off contact power switch. I've got this plugged into my Variac, which is isolated. Isolation transformer. I've got it on the 1.5 amp full scale, 175 watts. I've got the voltage turned down to minimum. So I'm just going to go ahead and turn the power on. And I'm going to very slowly ramp this up while I'm watching the current. And I really don't want to see it go above probably 75, maybe 100 watts at the most. And I'm just going to slowly ramp it up while I'm watching the current. So far it's looking very good. And so that should be about 120 volts right now. It's showing about 125. Our line voltage is about 115 volts. 125 output, and there's the current draw. Now I heard the relay click, so I'm going to shut the power back off. Turn the power back on. And we'll see if we hear the relay. There it is. Speaker relay engaged. So that looks good. Next we'll go ahead and hook up some speakers to it and give it some tests. Okay, let's go ahead and hit the power button. Lights up. Relay clicks.
California, customer of D for about a year. They did a great job explaining the work that needed to be done to my vehicle.
Little staticky.
And showed me pictures. They go above and beyond.
I think we're going to have to hit it with some Deoxit G5.
That's just the beginning. Visit the shop at 33.
Let's check AM, make sure AM works.
Online at D&E.
Get a local station here. Oh, I got no AM at all.
How else would...
Well, I'll have to contact the customer and see if he wants the AM repaired or not. Well, let's go ahead and shoot it with some Deoxit D5. Well, there's really not a practical way to show you this, but here goes. So I can get to this one and this one quite well, and I know you can't see it, but if I shoot my nozzle right down in there at an angle, I can get right into it. Okay, so this is the select switch. This one conveniently sits up on top of the board. So it's quite easy to service. We'll give it a few spritzes there. And I think we should be good again. Alright, so there it is. The FM works. Let me get some YouTube copyright-free audio going into it here. It works. It sounds really good. It has a lot of punch. Anyhow, I went ahead and cleaned all the controls and switches. Everything's working great there. I'm going to go ahead and quote my customer to repair the AM tuner portion of it and see if he wants to go ahead with that. That was not part of the original estimate, so we'll see if there's going to be a part 3 or not. Anyhow, I certainly hope you enjoyed the video on the Marantz SR8000 repair of the amplifier and preamplifier boards. Please consider subscribing and liking my channel. It really helps my channel grow. Also, you can go ahead and leave me a question, a comment, a concern in the comment section. You can also reach me on social media on Twitter, Instagram, or Facebook at NorCal715. And if you have a longer question, you can shoot me an email at norcal715videos@gmail.com. Once again, thanks for watching this video. I really appreciate it. Remember, with your help, we can keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody have a great day. Thanks for watching this video. I really appreciate it. Bye-bye. Alright, a little bit of bonus footage right here. Here is the inside of the STK power pack. So I pried it open. Some of the pins became detached. You can see some of them are still there. But you can see the driver transistors in here. There's the output transistor, the one that grenaded itself. There's some of the lower current drivers. This one has a small defect right in here. And this one, the defect is completely covering the two leads. I I believe this is probably the emitter and the base right here, but you can see the damage done. I can't tell if the driver transistors are in good shape or not. I don't unfortunately have a microscope to get down in here. I'm just using my regular camera. But anyhow, there you go, a little bonus footage, the inside of the STK3080 Mark II. Everybody have a great day. Thanks for watching. Bye-bye.